I could, but it's charging. We've used it almost every block today.
Okay.
Alright, so the interval, so would this interval be narrower if the researchers increase the level of confidence to 99%?
No,
Why not?
because that would make it wider.
That make it wider. Why is that?
Because you're more confident by capture.
Okay, so one, like to have more confidence it captures, you gotta make the interval wider. Two, remember a higher confidence level has a higher what value? Yeah, I think that'd be great. Let's not do it right now because I'll distract them. At the end of class, last 2 minutes of class, don't let me forget to pass your test back. What's gonna get bigger? What is making that interval wider? The what? Yeah, but what's gonna make that margin of error wider or bigger to have that higher capture rate? The confidence level does not affect the
critical value.
Thank you. The critical value will be a larger value to have a higher confidence level. All right.
That's why it's larger, bigger number.
Because you have a bigger number than you're multiplying by, right? Will the interval be narrower if the researchers increase the sample size of droplets?
Yeah, wait.
Because if we take your confidence interval, will it be narrower if we increase the sample size of the
Yes.
droplets?
Yes.
Larger sample size.
A larger sample size.
Less variability.
Yeah.
So one, less variability, but two, let's get more specific. Yeah, so it is B here. But why is it going to be smaller? There's something more specific we can reference. The standard error, remember, S sub x, there we go. Don't forget that n is bigger. Specifically addressing some of the issues some of us had on that free response on the original test. Makeup or retest start Monday. You can retest through next Thursday. If I quadruple that sample size, what's it going to do to my margin of error? It's going to half it, right? Because if I divide by the square root of 4n, what's the square root of 4? So I'm really dividing it by 2. So don't forget that detail. That's one of those things we need to remember. All right, 10 was the other one you said?
Yeah.
Do you remember which one distracted you? I can look it up. As long as you don't mind me exposing you.
Someone did video progress tag.
How dare he told me that new.
Okay. So you picked, actually on 9, you picked C. The interval will be wider if the researchers decrease the level of confidence. But again, if it's a less confident, the interval's going to be wider. Or it's going to be narrower, right?
I got that like this one.
Yeah. Okay. Researchers collected 2 different thank you samples, X and Y of temperatures in degrees Celsius of the habitat for Florida scrub lizards. You're a scrub lizard. The confidence interval 36 plus or minus 1.66 was constructed from sample X, and the confidence interval 36 plus or minus 1.08 was constructed from sample Y. Assume both samples had the same standard deviation. Which of the following statements could explain why the width of the confidence interval constructed from X is greater than the width of the confidence interval constructed from Y? So without even looking at the answer choices, what could explain this being a narrower interval?
Greater sample size.
So a higher sample size would cause my interval to get smaller because of this reasoning, right? What else could cause this to be smaller? Different confidence levels, right? We could be, what kind of confidence? If it's 1.08, would that be more or less? A lower confidence, right? Okay, so you pick the sample size is the same for X and Y, possible, but the confidence level used for the interval constructed from, I don't know what that says.
That might coincide around.
From X is less than the confidence level for Y.
Same idea that like,
Yeah.
so
So that would be a larger confidence, smaller confidence. By the way, I just have to address one quick thing from your test. Hey guys, if you collect crappy data, what's that going to do to your point estimate, to your statistic? It's going to be biased, right? So does your margin of error ever account for bias?
No.
Sure does not. What does the margin of error account for?
Randomness and the.
So sampling, variability.
The
Guys,
baseline.
nothing covers up bias. I refer to one of the multiple choice questions from the test. If you've got biased data, it doesn't matter how large your margin of error is, you're not capturing the parameter at the right rate. Your margin of error does not account for bias, it only accounts for sampling variability. Biased data is crap data, it's bad statistics, don't forget that. It's BS. Alright, you go with that though?
Yep,
Right?
yep.
Okay. And I say all that because that's one of the ones that hurt the most. I think almost half of us or more than half of us missed that question on the test. That's something we gotta remember. Bad data is bad data. Ms. Kowalski already passed out your next couple of review AP free response questions. I picked one that is very probability driven and it's a question 6, which means it's gonna stretch you a bit. I wanna point out on the normal AP free response questions, how long are you supposed to have per question roughly?
12.
13 minutes on average, okay? Typically, stuff from units 1 and 3 take the least amount of time. That's the stuff with univariate data. Those are the ones you really want to take 10 to 11 minutes, so that you have a little bit more time on the inferential procedures ones, which take 15-ish minutes usually. The question 6, though, how long do you usually have?
25.
25 minutes, right? So you have 25 minutes on this question 6 ones, but it's not that much longer, but it definitely takes more time to think. On this question 6, slow down, think through what's being said. It is one of those that I know the first time I looked at it, I said, what the heck is happening here? When I spent a little bit more time with it, just staying calm and thinking it through, it made sense. Okay, right, Serena?
Serena, get off Minecraft.
Oh my god.
Do I need to collect your phone? Okay.
She's watching the Minecraft movie.
So,
Yeah.
these are your AP review questions for Monday that are going to be due on Monday. You actually don't have a whole lot of other homework for me. I already talked about this with Peter. We don't have time for the projects that I would like to do.
Alright.
We got to keep going. But you need to do these AP for, actually, yeah, let's say that. I'm going to treat your AP free response review questions as your project. So it'll be an accumulated grade throughout the rest of this semester where this becomes your project grade.
Only these two? or more?
No, multiple. Yes. Okay, so treat this like your project. So we're not gonna have another paper to write, we're not gonna do another full project except the juniors will after the AP exam.
Oh my diddy.
What?
What?
We got the grades after.
No, you will not.
They will.
They will. Yes.
Okay,
No,
thanks.
we can wait.
Can we be honest?
Focusing here. DYU for y'all on Monday, and we'll have time to answer questions from the test. So I'm giving you the test back at the end of class. You have to email me questions this weekend. If I can answer the question via email, I will. If I cannot, I will answer it Monday. Make sense? Or if you want to stay after class for 2 minutes, I can as well then. Alright, today we were working on hypothesis tests for a mean. I think that's all I wanted to cover. Alright, so yesterday, I will say this 10.3, I want to look here briefly on confidence intervals for a difference of means. There's a couple of things that I want us to remember. So evaluating a claim, I think we talked about this, but I just want to make sure we remember. If our difference of means, that confidence interval is both negative, what do we have?
Using a new one.
With convincing evidence of what?
Into is bigger than 1.
Yep, is greater than 1, because the bigger number is being subtracted, right?
Which
Yeah.
gives you.
So, that idea. If they're both positive,
It's also
it's convincing evidence, but this time,
one's bigger than me too.
right, so. And what if one is negative and one is positive?
Not convincing evidence of ISO because 0 is captured. So there's a
Okay.
possibility that they'll
Bruh.
Yep. It is plausible that the difference is 0. Does it matter if it's negative 2.7 comma 0.01?
No.
Nope. 0 is still plausible, so there's not convincing evidence they are different. I need us to take time to slow down on writing out the equations. I need y'all to remember you have a freaking formula sheet, okay? If we're doing a confidence interval, what's my general formula for the confidence interval?
Point estimate plus
So-
x.
And what's another word for point estimate, by the way?
X bar.
Not always x bar, but it is a statistic, right?
Oh, shoot.
X bar is a statistic for mu, and p hat is a statistic for mu, okay? Plus or minus
Critical value.
critical value,
Times standard error.
standard error, okay? And then remember, this critical value is what when we're dealing with proportions?
So it's like the.
I was saying, if we're dealing with proportions, it's
T stuff.
z, proportions?
Oh,
Proportions, z star,
Mean is T.
mean is t. Okay,
But you find that through the confidence.
The line never
Right?
stops.
Not the proportions of
what do you mean?
I thought like, cause they give you like confidence level and then you use the.
The confidence level and
And
the
then
degrees
you
of
use the
freedom.
chart thing to
Yes,
find
yeah.
the, yeah.
Yeah.
You are.
Remember, if the degrees of freedom is infinity, then
Then
it's just z, right? And then standard error, guys, again, go back to your formula sheet. I just saw this on a couple of ours, and I have the formula sheet here. Please notice, like, again, it's here. They've given it to us. Okay, if we have a difference of means, which formula am I using for the standard error?
Alright, yeah.
By the way, where in the world is this formula coming from?
The atom, because chaos always increases.
Okay, so there's chaos always increasing. What's Braden referring to there? He's referring to,
Entropy.
well, that entropy idea, but I'm talking statistics. What? Combining random variables. Remember, if I have mu sub x minus y, because that's essentially what we're doing, x bar 1 minus x bar 2, or if I have random variable x minus y is what I should say, how do I find the standard deviation of x minus y? I add what? The variances, right?
Yeah.
So remember, that's what we're talking about here. Why in the world is it S1 squared divided by N1? Because that's my standard deviation squared. It's the variance. Like, these are not magical, crazy formulas. They're based on the idea of combining random variables that we have studied for a couple of units now. It goes all the way back to probability, right? So we saw it in probability, we saw it in sampling distributions, and we saw it last unit with proportions, but we are adding the variances and then taking the square root. All right. I didn't get a chance to do a video for this Check Your Understanding. I will get that done this weekend along with a couple more and upload it. Just be careful when you do this. What are the 4 things you gotta hit? 4C method of inference, so choose, check, calculate, and include. Guys, use your formula sheet to write out the formulas, then plug in your values if anything, and then use the actual calculator to run the test, or the confidence interval. Now, one thing I want to talk about, just because of what I saw a student do on this, and this is a phenomenal mistake to make, so I want us to learn from it. When we check our conditions here, what conditions do we need to check?
Random.
So did I just put random and check mark, Jay?
Random sample.
Random sample.
Now y'all need to read again, this is important. Random sampling is not here.
It's
Assignments.
Random assignments. Okay, so 2 samples
Probably.
were randomly assigned. So here's an important question. Do I need to talk about independence here?
Yeah.
If I'm randomly assigning,
Well,
can they
no,
be
no, no, no,
independent?
never mind.
See what I'm saying? I need y'all to remember, when we're randomly sampling, they have to be 2 independent samples.
Yeah.
But if I'm randomly assigning, it's 1 sample that were volunteers in the first place, and I'm randomly assigning to treatments. You just have to say they were randomly assigned. And Jay, I was referring on your test, I think you just literally put random and check. Don't do that. You gotta say. There have been AP exam rubrics in the past where if that's all you put, they did not give you credit for
So what do you need to put?
checking. 2 samples were randomly assigned. Random sampling was stated. And by the way, don't ever say it was an SRS unless they tell you it was a simple random sample. You just need to say it was a random sample. If that's all they say, put random sample. Don't put SRS for simple random sample. okay? Just literally a short statement. I know it's goofy, and I hear you, it is goofy.
What?
That's what it says on the rubric, so we're gonna make sure we don't lose out on credit, okay? Do I need to check my 10% condition here?
No.
I mean, if it's
No.
already.
Yeah.
For cause and effect.
I'm looking for cause and effect.
No.
Well,
I mean,
because your population is like the volunteers or something like that. You know what I'm getting at?
Yeah.
What is the 10% condition for?
For like.
Without replacement.
Sampling without replacement. Guys, are we sampling at all?
no.
We're gonna be exciting. We don't have to do 10%. Do not do 10% with experiments.
So, what do you do it anyways?
Nope, that's it.
What do you do it anyways? Do
There's
you have
been
out?
some rubrics where they actually say that you drop from an E to a P or a P to an I. That's why you just have to, but that's why you need to, it is, at least for that section, but for that section, it'll drop you a score because you are missing the fact that the 10% condition is for sampling without replacement. That's when you have to, it's just a detail I'm gonna keep hammering, we gotta remember, 10% is when you're sampling without replacement. Normality, do we have approximately normal sampling distributions?
Sure.
Not a sure, yes or no?
Actually, we can find out.
We don't have to find out. Nate, you say yes, why?
Central limit theory?
Can we use the central limit theorem here, guys?
Yeah,
There's a lot of
sufficient 9.
975 and 1050, are those sufficiently large for the central limit theorem?
Maybe.
Kind of small.
Just, it's light, right? Don't forget with this, I will make a note, how many sampling distributions need to be approximately normal?
30?
No, how many sampling distributions?
Both.
Both. So I just want to make sure it's clear, you always have to check that you have at least, you have both sampling distributions approximately normal. One could be satisfied by the central limit theorem, the other one can be satisfied by the sample shows no strong skewness or outliers, but you have to have, you have to have those things. All right. Then we did 10.4, confidence interval for a mean difference. This is what we ended yesterday on, and we didn't get a chance to do these notes at all. So remember, this is when we took y'all's, not sleep data, your screen time data, which was appalling, by the
What do
way.
you mean?
1,000 plus minutes or
good here,
a single day. I thought my data was appalling, and then
What was
like
yours?
way less than all of you.
No,
It
tell
was-
me, what was your average screen time?
23 hours a full day, you
You're an
quit me.
adult, you have a lot more responsibilities, you have to run a house, and we don't. So while you have to do all adult stuff, we can sit over.
And you gotta
I
teach the grade.
We got TikTok.
I still don't under.
You have a wife. You have a wife. We just sit alone.
drive way farther. You got kids.
Some of y'all got some boo things, but getting back to the stats.
Why do you always
Right here.
Come on.
So look, when we have a confidence interval for a mean difference, okay? If our mean difference interval captures 0, what is this telling us?
There's there might be no
So
difference.
no difference is what?
Mr. King,
Plausible.
can I say something?
No, ma'am.
Okay.
No difference is possible.
It's about this.
What?
So, you know how you was y'all zombie for 19 hours? It's because 10 hours was music, but I played music when I was asleep. So technically it was 9 hours for Sunday.
Oh, that's so real.
Did your phone turn off?
No, I had it was on my
Wait,
iPad.
19
Wait,
hours?
my phone don't do
Yeah, so
that.
technically it was 9 hours because my iPad was open for 10 hours.
19 hours?
That's
It
crazy.
was minus 10.
So when it is
my iPad was
all,
open.
when the
I'm trying to go
interval
-3, bro.
is
Come on.
completely less than 0, we have what? Convincing evidence of what?
P1 being less than P2.
Be careful.
Not P, sorry, you, my bad.
But we're also not, we don't have two means anymore. Remember how yesterday we paired the data together. So remember, when we actually did a 2-sample test yesterday, or 2-sample interval. Let me pull this data back up. Is this it? No.
Do you know what I'm talking about?
Here we go. So right here, I need y'all to look at this.
It's looking fire.
So this is when we did a 2-sample interval yesterday. We had a lower bound of -440.9 and an upper bound of 28.4, right? And so we looked at that and we're like, well, is there convincing evidence that Monday and Sunday were different? No. But that's because we did 2 interval, or we did a 2 sample one. But remember how I gave us the data in a meaningfully paired way, what do we call that?
Combined.
Match pairs.
Match pairs.
Match pairs or paired data. Technically it's not a match pairs design because it wasn't an experiment, but it is paired data. So I was able to take the difference of each of these individuals, and now do we have convincing evidence of a difference in Sunday and Monday?
Yes.
Yes, right? Because what happened to our variability? It dropped, right? We had the same exact point estimate. I need y'all to notice that. My statistic was the same, but the variability was decreased because typically people who spent more time on one day spent more time on the other day. And so we reduced that variability. Now do we have convincing evidence of a difference?
How do we do this on an AP exam?
What do you mean?
Calculator.
Like, I don't know.
Like, what do you mean though?
What would a question like this look like?
So I've seen a couple. One is where, I'll show you some, but I've seen one where they gave some information about men, some information about women, and then there was a section where it was like the difference between a man and a woman. And like it could, if it's like a husband and wife, those are meaningfully paired in a certain way, right? So that could be considered paired data, where you do the difference and then you run the test with the difference. So you have to recognize, is it 2 sample or is it 1 sample? Now, at the same time, what I'm getting to right here is this. With this 4C, well then, if it's this way, we have convincing evidence of what?
It's above 0.
It's greater than 0, okay. But here, I want to talk about the 4C method. Now, in this 4C method, when we talk about our choose for a mean difference, what procedure should we use?
Is it like matched T something?
You can make it simpler than that.
I don't
It's
know.
a T interval.
It's a T interval. It's a, how many sample in this case?
1 sample.
It's now become 1 sample. So we started out with 2 sets of data, but we took a difference and got how much data? Or how many samples? 1. So we would just call this a 1 sample
Repeatable.
T interval for what?
For matched
For
pair.
match period.
You could, I wouldn't call it.
Or
That's what it said on
Is
the
it
eight.
not different?
That's what it said on the progress check.
Is that what you're talking about with Nate? Like the mean difference and difference of means?
So yeah, they might call it a matched pairs and they might accept that. What I would do if I was doing it on a free response, and so Serena, just read the language that's there and go with it, because there'll be enough to eliminate other answers. But on the free response, I would say for a mean difference,
Okay.
right? So it's a mean difference, so the mean of the difference, or a difference of means. And so the question comes down to how many means, how many samples do you have?
Do I have to explicitly say like difference of means and difference?
Say that one more time.
Like do you have to say like mean difference and like difference of means and all?
I would use that language,
Also,
yes.
because
It
they-
also helps you think through which procedure you're using and which type of interval, stuff like that. I would,
Also, don't think
I
they're 2 different things.
right, Sinai?
Like a difference of,
What?
like isn't a difference of means and a mean difference between 2 different things anyway?
Yeah, so when we say a
I'm
mean
not
difference, we're looking at mu sub d, so the mean difference, and then a difference of
Is
means
where you subtract 2 and get the difference.
I think this lined
is
up good.
mu1 minus mu2. And remember, they'll have the same point estimate, this one will have less sampling variability. Alright, so when we check, what do we need to check?
Condition.
So random,
Sample or assignments.
random assignment or random sample, what else?
And
Approximate normality, and 10% is sampling without replacement. And so exactly the same, but I want to talk about the calculate really quickly. Because you know how the conclusion's going to go? Exactly the same as it always has, right? We are this percent confident that the interval from blank to blank captures the true context, right? So keep that in mind and don't write the word context, right? I know it's a struggle for some of us.
Can I do that?
Yeah, you were the first one who did that the original time.
Oh.
Yeah.
He hasn't given it up.
Like literally wrote down the word context, like bring it in. Yes, I know it was months ago, but it is, well, weeks. Calculate, okay, when we calculate for this interval, again, what's my general formula?
Statistic plus or minus critical value times.
So statistic, my point estimate, plus or minus critical value times standard error, okay? Now, what is going to be my statistic? So remember, by the way, specific does not mean substitute your values in. This is where we put the variable things in there. The actual, what the statistic is. What's my statistic in this case?
X bar difference.
X bar difference. Notice, and that's why I would name it up here for a mean difference. You can even say X bar D or mu sub D, but that's my point estimate, the sample mean of the difference. Plus or minus, what's my critical value going to be?
T star.
T star times,
Over the time. I mean, yeah.
over.
So it's
Is
not.
that it?
I'm missing something.
Oh, squared. Right? Nope.
Something very small. Isn't it this, it's the standard, so standard deviation of what? The standard deviation of the differences. Yeah, standard deviation of those differences, okay? But notice, we don't have to stress this a ton, I need y'all to hear me on this. This is essentially a one sample interval, T interval. If you don't write the D in there, guess what? They're not gonna care. Nope, not at all. You just need to recognize that it's the same as a one sample T interval, and then substitute in, and use that calculator. Alright. We got all that down. Sanaya, did you ever find your sheets of paper?
It was in the next slide.
Everybody got that down for 10.4?
We're gonna write it down.
There's a second page, my guy. I'm gonna give y'all 60 seconds while someone puts whiteout all over one of my books.
Wait, for real?
Where?
It's a Carnegie Learning.
That's
It's
probably.
on
Oh
yours.
yeah, that's that.
Don't disrespect
That don't
mine.
matter.
Look, it literally looks the exact
That
same,
legit doesn't
doesn't it?
matter, just kidding. No one uses it.
It looks
So
like.
I do.
I mean, like for other classes, They just give it to us. They give it to us, but they never assign anything. So like, have you decided your demo down yet?
Oh, it's not.
Like your demo, like dates, yes. You need if you want like good classes.
It's not gonna be able to tell the differences anymore.
Yeah.
No, I think it will.
There's no difference. Oh,
Okay,
it's
a
okay.
handful of us are taking notes. I appreciate that. For the rest who aren't,
You're
or
welcome.
if we've already done it, I really appreciate that.
You're welcome.
Yeah, you're
I
welcome.
actually like it.
Serena, why is your paper empty?
It's not empty. I literally worked so much.
Oh.
Okay.
You're actually so fake.
I'm very confused.
You're like,
Oh,
I
yeah.
don't recognize that.
Everyone did it like really late, like in August.
Yeah, I'm not gonna do that.
Yeah.
Jade, I can see the inside of your dirty mouth.
Junior,
Oh.
that's the only thing that's not. Jade, do you have an A days?
Mr. Kenny.
I don't know what's worse, your comment or what he's doing.
Mr. Kenny.
I think you
Please
should
look at
move
Jade.
tables.
No, no.
Mr. Kenny's face. Did you see? He knows for the fact that he's been doing
And
something.
then we'll get back on it Monday.
Yeah.
Alright. Alright, same thing with check your understanding. I will post a video on it tonight
Okay.
at some point. Alright. We're on to 11.1.
Woo.
That means,
Sounds like
That's such a like
Do we have that
massive.
already?
Oh.
yes, you have it already. It's in the same packet that I gave you originally. Okay. When y'all got that giant stack, you're like, what?
Freaking packet, bro.
I
It's
know.
worse than the Shalom one.
No, it's not. No.
Yes, it
I'm
is.
so sick of that class.
Hey, being respectful.
What is it matter for? She did
Right here. So AP Stats teacher from East Kentwood wondered if her students' AP exam scores from the previous year were better than the scores from rival high school to the north. She took a random sample of 10 of her students from last year and found a mean AP score of 3.8.
That's good.
That's pretty darn good, isn't it?
That's good.
Yeah.
That's a
What do you look for?
What do I hope for this year?
Oh, 5?
Mean of 5, yeah.
Oh.
I mean,
My bad. I'm
my
gonna drop it.
mean last year was 3.5, a little bit higher, I think. So
That's still pretty good.
Okay, Shaw.
Yeah. Alright.
I had some good students last year.
That's
Yes, we want
Ashley
that as
Divine.
well. Lito.
It's Divine.
What did Josh get?
Whatever you say.
He was a 4 or a 5. I think he was a 4.
And Austin?
He was a 4.
That's pretty good.
I was like, I had a lot of 4s and 5s. I had
Wait, Lindsay.
What, then who made threes?
Stop.
Ooh.
a couple of juniors.
Ooh, I can guess.
Wasn't Madison Kaufman in that class?
No way.
She was for a hot second.
That's
Alright,
crazy.
Before she
Actually, I
got,
have some
what,
news on
expelled?
PE.
How?
She got
Alright.
spelled.
so ladies and gents, right here,
She
I
was
need
like
y'all
awesome.
to, I don't know, maybe do some stats. I need y'all to work through numbers 1 and 2, thank you. I'm gonna give y'all just a couple minutes, I'll check in on y'all, work within your small groups, and we'll bring it back together.
Population.
All schools,
Okay.
both schools.
All of this is blah, 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 score, exact scores and like.
Okay, so is it the students or is it the scores? Okay, so we need to be careful, right? It's all scores from where?
Full students.
So from East Kentwood, right? So all AP statistics scores from East Kentwood, right? Notice the parameter or the population needs to be what we are collecting data about. Yes, we're collecting data about people, but really in this case, it's the scores. Yeah, the parameter, we need to be clear with our language here. What do we need to write? True mean or population mean. So true mean. So fun fact, when you say true mean, it already implies all. If you say population mean, it already implies all. So we just have to say true mean,
School.
AP,
I know stats.
statistics.
But saying that would hurt you, right?
It would not hurt you. Statistics,
Or that's up to
scores, at, yeah, EK for East Kentwood would be fine. Okay. So what's our sample?
That's scores.
So the 10
From last year.
10 students scores from last year, okay? Statistic,
The mean of 3.8.
X bar equals.
notice we use X bar, right? Sample mean. Alrighty, so
I got a 1.
Rival High School had a mean of 3.11. There's two possible explanations for why the sample from East Kentwood is greater than that. So notice that's the true mean for Rival High School. So what is Rival High School going to claim? They're going to say that, I mean, like realistically, in the real language of the world, East Kentwood's going to not just claim that, or Rival's not just going to claim that East Kentwood's the same. They're going to say East Kentwood is less, right, or the same, right? So they're going to claim, hey, East Kentwood, they're not better than us. Their true mean is 3.11 or less. Huh?
Say that.
What?
Like in the
Yeah,
question. Maybe it's just a language thing. I'm like, where does it say that?
Well, what is this the same as? What should that word claim make us say? Yeah, this is the null hypothesis.
Yeah, and doesn't that equal?
So yes, and so that's what I'm talking about. So when we actually run a hypothesis test, right, we're gonna use mu is equal to. But what I'm saying is in the real world context, that's not how Rival High School is gonna say it. Rival High School is gonna say you're not better than us. Yeah. So what would East Kentwood claim? What's our alternative?
Greater than
You-
3.11.
Yeah, it says that.
Yeah, so remember the alternative is what we're trying to collect evidence for. Now what I want to remind us of is this. What are the two possible explanations for why the sample is greater?
They're just
Sampling
better.
variability.
One, so sampling variability, so it happens by what? So sampling variability, well hold on, let me, null is true, but by chance alone. And what's the alternate?
Alternate is that null is wrong.
They have better teachers.
So 2, the alternate is true, and null is false, right? So either we got that statistic by chance alone, or the alternate's true. And it's not necessarily better teachers. Sometimes it comes down to money and cheating. I don't know about that, but definitely money and resources outside the classroom. Like the reality is, you look at an AP classroom, the vast majority of the explanation of students in that classroom can be explained by family resources, not at all by the actual students' natural intellectual ability.
Well, I mean, like,
It's not 100%, but yes.
people who like have less money tend to.
Also not take AP classes.
People,
Not take-
I want you to think about
AP
this,
classes are
like
also
in the kindest way. Like Joseph's an anomaly, right?
Yeah.
Most people who are in his situation have to work. and have no shot in the P world.
Will.
Like, that's the reality, right?
All he does is make fun of me in class.
Honestly, that dude's
You deserve it.
whoa, I don't know about all that.
Okay,
Yeah,
My
you
point
can-
is, again, like, the people who are,
Yeah,
like,
that's a
think,
lot.
why does Northridge have better ACT scores than
Because
Hillcrest?
they're rich
Cause they
AF.
can pay you to.
There are quite a few of them that pay me for ACT work, but in general, it's true. In general, what?
Trader.
I mean, if, I don't, listen,
He's just
I need the money, alright. But, that's also why I started the class over at Shelton State, to help people who can't pay that price. Anyways,
Is it like $300 still?
Yeah, it's still.
that's way cheaper than what it is when you're doing small
Oh,
group with
yeah.
me. Yeah,
How
okay.
much is it with you?
$300.
We can talk about it later. Alright, I charge per hour, not for the whole thing. Yeah, anyways.
Expensive.
So, hey look,
200.
getting back to this though. Money explains a lot. That's my main point here. So, all that to say, I don't know why I got over for that. Here we go. Boop. So to test East Kentwood's claim, we're one, assuming the true mean is 3.11, and then find the probability that a sample of 10 students would get a sample mean of 3.8 purely by chance alone. So you have a, what's that thing called that y'all have that has those scores? No, it's later in the packet.
This thing.
What's this thing called?
Table.
It's not what I'm gonna call it in stats.
Stat
Table
table.
of contents.
This has every single student's AP score.
Populate, I don't know.
Oh, census.
A what?
Sample space.
No.
That.
We frame something, sampling frame.
Sampling frame, guys. We got a sampling frame here. It's not just the population; it is the population also labeled, right? There's a sampling frame right here.
250
Okay.
students.
Say again. So the census is actually the process of collecting that data. That's the sampling frame itself. Okay, so take a random sample of 10 students. How are you going to do that?
Random
How?
integer.
How?
So random integer and 1 to what?
1 to 2 something.
250. Is it only 250?
There you go.
253.
Should we see it?
If you didn't, you can definitely take second to seed it if you want. That would not be a bad idea. So, but random integer 1 to 253. Write down your 10 scores. Find your average. Why are you looking at me like we're crazy?
Because I was following along, I was using us to do it.
The next part. Find your 10 AP scores. Here's the data.
So get a calculator, do it right on and
Do you not
How many times do you want to run this?
then. Anytime.
Do you calculate that?
Oh, I
You-
did
you
that
have to-
one, but I'll get another one, but I looked at that.
Okay. Bring it to school with you. Go get it.
Wait.
Go get your calculator.
No.
Y'all have your clear tape.
You said 2 times. Just kidding.
It says on there
Uh,
2 times.
I know. Just get 2 numbers.
Okay, but
I
so-
can't feel
What?
anything.
And some of them taste really bad if you mix it. So the powder tastes better.
It's mango.
Or rather, you avoid the
That's
taste.
not what I wanted.
Yeah, if you have like flavor ones, I think.
Yeah, no, that one.
Okay. So, we have our dot plots over here. What does each dot over there represent?
10
A sample.
The mean,
So,
the mean of a
a
sample
mean-
of 10.
10
AP score for n equals what? 10. We've done this in the past where we put what on each of those dots?
Like P
X bar.
No,
Was
like
a p hat or an
X bar.
X bar? Because each of those dots is a what?
Sample statistic.
Sample
So it's
of
statistic.
Forgot something.
Statistic X bar, right?
Stop
So
harassing
we
me.
need to remember each dot is a statistic, an X bar. Now, with that in mind, I'm looking over there. For a school with a mean AP score of 3.11, what is the probability, because we're assuming, remember, that the actual average is 3.11, what is the probability that a sample of 10 students gets an X bar of 3.8 or greater? By the way, what did we just create over here?
Sampling distribution.
Sampling distribution-ish. Now, first off, I will say this. It's definitely not a true sampling distribution, because what is required for that?
All possible
Everything.
samples.
Every possible combination of size 10, right? Did we do all possible combinations of size 10 for 253 students?
No.
That'd be a lot of work.
That'd be a lot of work, and that's a no. That's a no for me, dog. What did we create then, possibly?
A partial.
A sample distribution.
A sample.
You can say it's an
Approximation.
approximate sampling distribution.
A sample sampling distribution.
But really, what we just ran
Sample
was
square.
What?
Sigma.
Simulation. Simulation.
we just did a simulation. So remember, when we create that sampling distribution in this way, we do a simulation to estimate these things. So what is the likelihood that if the true mean was 3.11, we get 3.8 or more extreme?
Like
Very unlikely.
one or out of something.
How many are there?
Not that often. It's like
21.
Out of 21.
1 out of 21. So what is that?
Like
0.04,
6%.
Okay.
Wait, like
0.0.
4%. Slightly less than 5%.
4.76%.
Okay, thank you. Slightly less than 5%, Jaden. 4.76%?
Something like
I
that.
got 0 point.
Yeah,
I got 0 point.
Well, yeah, 'cause
4.76. Okay, so
Stop reading.
how likely is that to happen by chance alone?
Pretty
Not
unlikely.
very likely. So, what is the probability that a sample of 10 students gives that X bar or greater? That's 1 out of 21. So, probability that X bar is greater than or equal to 3.8 is 1 out of 21 or 0.0476. Based on your answer to question 6, does East Kent Woods' observed results give convincing evidence they have a greater mean AP score?
Depends on what our
significance level.
Say that again, Peter. I love that response.
depends on what our significance level is.
Depends on our significance level.
Yeah.
What significance level is that convincing evidence at?
5.
Is it 0.05?
So it'd be convincing
At 5 or greater.
at alpha equals 0.05. Are there any other alpha levels that are pretty common?
0.01.
0.1 is common.
0.001.
0.001. So which of these would this be convincing evidence at?
The first one.
The first one?
The first
Oh,
one
and the
the
second.
third one.
No.
What?
No.
We're gonna be on.
Not.
Oh, my bad.
To read that.
So- What would be a reason that we might want to do alpha of 0.05 and alpha of 0.1 instead of 0.01?
Two, times 2.
Not, there's an error.
Increase the
So it's more about the errors. Remember, we don't want to fudge the numbers,
Is it-
right?
Oh,
Type
yeah,
one
because
error.
if you get an error.
So which one, this would make what less likely?
Type 1.
A type 1 error, right? But if we did this, it's going to make what more likely?
Type
A type 2 error. So we actually need to make a decision on alpha before or after we do the test?
Before.
Before, okay. So that's something to keep in mind. One thing also I will say, if you talk to a math professor of mine at UA and a couple other statisticians, the move within the real statistics field has been, instead of setting an alpha level, a significance level, we usually just run the calculation and we say at this level we have statistically convincing evidence. So that is a newer move that they do more often. And so, I mean, if it's anything above 0.1, we don't ever consider that statistically significant, but usually 0.05 or lower. So it's statistically significant at this alpha level or something to that effect, or they interpret the p-value. So, do we have convincing evidence? Yes, at those two common significance levels. Anybody need a second to write any notes down
Yes.
for their future forgetful
My
selves?
test for that ink is gonna take me like 5 years.
No, you could just, get a different one.
Oh, I love this pen.
Senior Kenny.
Yes, Michael,
Grado, you're Albano.
you made it to the bathroom.
Thank you.
How
See,
do you-
I'm glad you know
May I
Spanish.
go to the
I'm
bathroom?
glad you know
This
Spanish.
is
You're going to Maggie, I know what you meant.
El Baño.
No, it was pretty bad Spanish, but I
I
couldn't even hear the Puedo at first. I was like, what is he saying?
didn't know what he said. I don't know what he said.
Same baño. What? It means bathroom.
Puedo.
Puedo, may I?
May I go?
Oh, I thought he said.
Here we go.
I heard B.
He did at the end, but Puedo, may I, ir al baño, to go to the bathroom.
Puedo, you said
Yeah.
you're
Huh?
bueno. I was like,
Puedo's can.
Huh?
Puedo's can.
Okay, but it also means may I.
Yeah.
Mine's
tomato, tomato.
class. So it's fine. Spanish.
Yeah.
I'm so sorry, I know
Tomato.
things. I'll quit.
Oh.
Good.
Oh.
Oh.
It's smoke.
Oh, that's crazy.
Yeah, I know how to say fish in French.
I know how to
What
say
is
it.
it? Huh?
What is it?
Like poisson.
Les
Les
poissons.
poissons.
Y'all are
I love les poissons.
You are not him.
Alright,
It's my
so we got 30 minutes to finish, hopefully the next lesson as well.
Okay.
We got that. It's 30
Not even
minutes.
like a.
Say
light.
again.
It's 30 minutes, we got that.
So hypotheses, learning target number 1. What are the possible hypotheses for a significance test for a mean?
True, mean. Wait. Oh, wait, for null.
Yeah, null could
Oh.
be,
True mean is equal to something.
so the mean is equal to, what are we gonna kind of use here to indicate that it's the null hypothesis? It's what we see in the calculator.
The calculator.
Oh, yeah.
What else?
I need to get
Do we not remember seeing this? Let's see if there's a different notation that they use. They just say null value. That means null value. We'll just say that. It just means null value. What are the alternatives?
No.
Not equal to.
So mu is not equal
Just like
to
Greater.
the null.
any inequality for real.
Yeah.
Oh my.
That's
Okay.
Be careful, it's not any inequality.
Ugh.
greater than.
Which inequalities do we not use?
Or equal to.
Greater than or equal to, less than or equal to.
You know, I didn't realize that why an inequality is called an inequality until like 3 days ago.
Serena.
Honestly, y'all say that, most people don't think through the fact that n just means not and equality means it's not equal. Like, most people are not aware of that detail. Don't let them bully you, that is a normal thing to
Well, I
not
didn't
do.
realize.
You know, when you
so
use
then-
zero-
like,
You know what
the compound, I
fraction
didn't
means?
think about it.
When you use
Serena, do
zero
you know
or
what
null
fraction
hypothesis,
means?
Why don't you put a dash?
Part
through it?
of.
I feel like you just kind of show your color's gonna add it.
No, because sometimes if you.
Jen,
put
I hope you
action
fall
in,
off that
it's
desk
something
and
else.
break your neck.
Is that true?
What?
Yeah.
What?
Click that, check, click that, check, click
What are you
that.
talking about? Hold up, pause, what are you saying?
That is
So
a,
much tension in the room.
that is not protected speech.
And then zero.
Yeah.
Why don't you?
That's
I heard
dash
it.
right?
Those are fighting words.
That's
Those are
technically
fighting
it's
words.
not
That's
a
the
correct
null set.
because she didn't say she
Not
did
null.
not. It's actually.
Like, null, like, a null
Those
set
would
is a
be
set
words
that
that
is
will make you punch her in the face.
It's just a
It
manifestation.
has a mathematical meaning.
Those are fighting words, I agree, but.
Yeah. That's right, that's what I was thinking.
No.
Alright,
Fighting words?
hey,
Are you serious?
are you serious?
What did I do?
Have you finished writing all this?
I'm writing right now. I'm not even.
And run in your mouth. I
I'm
need
not even
writing.
what?
I know more than her.
Are y'all done writing though?
Yeah.
Okay, that's my problem. I need us right. Ignore him. He says a lot of things.
It was the reason.
I ignore him 90% of the time. Alright, if it's a null value, if it's not equal to the null value, what type of test is this?
Two.
A two tail or two-sided test. So don't forget, you get one tail and then you have to copy it over to the other side. You have to end up doubling that area. If it's a less than or a greater than, it is one tail or one-sided. Okay?
No, that's what I'm writing right now.
And don't forget, whenever you say mu or you say mu1 minus mu2, or as Serena desperately wants mu minus mu2, whatever, then you need to define. That's the point.
Huh?
That was the joke, Michael.
Oh, he wasn't
He
here.
wasn't here yesterday, that's right. Alright, mu is the true blank
Context.
in
True
context.
Hey.
Okay?
Hey, we write context?
Write the word context every time, okay?
Context.
Oh yeah, I'm flipping that.
I got
I'm flipping
you.
that.
This joke is getting too far, you guys.
Full conclusion. When we do a full conclusion, what do we need? How do we start out our conclusion?
Interpret
We do
the
the full
mean
thing.
value.
We all.
So we interpret, and how do we interpret?
Assuming that the null is blah 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 blah.
So assuming the
No, in context.
mean equals blank,
Context.
the likelihood of getting
X bar equals blah 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 or more extreme.
X bar equaling blank or more extreme by a chance alone is blank. Don't ever forget that a p-value, right, that's what a p-value is assuming the null was true. What is the likelihood of getting that statistic or more extreme by chance alone? Because then we do a conclusion based on that. If my p-value is low, and when do we consider our p-value low?
What is below our statistic? Significance
The
level.
significance level. So when the p-value is low, less than our significance level, what are we saying in that case?
We have convincing
We
evidence.
failed, no, we rejected
we
null
reject
hypothesis
hypothesis.
because we found convincing evidence for our alternative hypothesis.
So remember that what we're saying is that is unlikely to happen
By chance.
by chance alone. So unlikely that we don't think what is true.
That
The null, right? The whole idea is that if our p-value, our probability is so low or super low, then we reject our null. So we reject the null hypothesis. Make sure you put the word context in there, Braden. Reject the null hypothesis that blah 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 because we have convincing evidence. What is that convincing evidence, by the way?
if it's below
P-value.
The p-value is
Below the.
below alpha, right? So p-value is less than alpha for, we have convincing evidence for the alternative. And again, context. Okay.
I'm gonna do that too.
What if the p-value though was actually greater than alpha?
We failed to reject the null.
Okay, so, children.
Yeah, there's too much going on.
Okay. So notice we fail to reject the null hypothesis when we don't have convincing evidence.
Hey, but you can use that. Mine just
No.
says it.
Alright, thank you so much.
So notice I did the fail to reject in red so that you can have that note, right? So we fail to reject when we don't have convincing evidence, and then we reject the null when we do have convincing evidence. Yes, Michael?
No. I was not waving my head, I was just like.
Oh my god.
Alright, I'll upload the solutions to check your understanding later. Yes. That's why I called them children. Alright. So, I have 3 purple markers in my pocket.
No one's looking for the
Oh,
board.
that's not
He was
purple.
looking for the
I'll
board.
take one.
purple.
I'll take one.
That middle one?
There was
No,
one
it's not
behind
purple,
it.
there's 3 purples behind it.
I thought your eyes were amazing, Serena.
They are. I've lost my vision.
I'll take them all.
Block it.
Okay. So, I hope we have all this information down. I'm erasing the stuff about the hypotheses. So, we are moving on to 11.2, which is our wrap-up of hypothesis testing for 1 samples means. So, for many years, doctors have told people that normal body temperature is 98.6 degrees Fahrenheit. Is that true, Braden?
Yes.
No.
Oh.
Hasn't it gone down?
It's not
Well, it
97.8.
depends on where you get it,
I thought
but it's not, it's
97.8.
between 97.6 to 99.6 is considered normal range for old temperature.
Wait, can we check everything?
Now for
Wait.
that thing,
That sounds like a great idea, Michael! Yay! So, today we will find out if this is true. Record your body temperature at the front of the room. Think of the class as a simple random sample for all high school students.
Oh.
It's
And
not
This
representative.
is a subject.
no, we're
What
not.
about fever?
So,
That's
what I
true,
need
yeah.
you to do is we're going to record our temperature and we're going to write it on the far left side over there. Alright, let's go.
Something to
Serena,
consider
stop
is that
manipulating
the
the
average
data.
temperature of
Well,
that is
what,
actually
Serena, why is there a hot patch on your
Is
forehead?
that gonna give me brain cancer?
No.
Yeah, 100%. Get Shell up here. Let's
Serena,
write
stop
some
manipulating.
values
That
on
mess
there.
with the data.
Your face
And
is
then we'll
red.
add one.
Your face is red.
Well, let's just write our data for now.
Wait, it's in the mouth?
God dang.
dude.
Well, she said it was in the mouth, so I was like, what?
97.3.
Oh, wait, what's my old temperature? My outside is
Well,
hot. My inside is cold.
98.
No, your inside's a lot hotter than your outside.
You literally dated Farmer. No, go away. Come back.
Wait, it hurts.
That's the line.
Receding.
Wait,
What's
here,
wrong with your head? Did it work?
No, you told me to do it.
Let's go also 97.8. There we go. Yep, 97.8. We're good.
It hurts.
Good. 97.5.
Oh my god. You're like the guy with the like the.
98.
Declaration of Independence. Shut the frick up. Shut up.
John Hancock.
Yes.
97.8.
Bro, all that.
All that you have to think for me, bro.
Sorry. Oh my gosh, I'm getting pushed around.
Anybody else gonna hit 92?
I thought it was only like
97.3. Just
every
you,
point
Michael.
two.
Crazy thing is, I always feel cold.
Ah.
Oh my goodness.
Well, you know that hot air always
Yeah, we
moves
definitely
from
have
a warmer body to a colder body, so that could mean the temperature is leaving your body.
Where am I?
Which is why when you get 6 of the time you get cold chills.
Tonight?
says.
That's not my name.
Shut
Alright.
Do it now. Do it now. Who saw
I think
that?
I thought your name was tonight. I told you.
That's from the song.
Hey guys, y'all know. Oh my gosh. Has anybody written their data on here?
Erase it.
I
Erase
wanna
it.
go home.
That's every
Michael, get out the way!
Stop. Grab a seat, grab a seat. Write your data down.
I cannot play
Put your data.
data.
Hey, guys, put your data in a calculator and list in spreadsheets. Let's go.
I'm gonna the bubble letters or something.
Yeah, the one figure.
There's no.
Is that everybody's information?
It's not a gun.
Who's the fat one?
That's a 9.
That's what he does.
That was supposed to.
It's a, never mind.
Looks like an A.
Wow.
I'm not gonna say
Hey,
that.
Wait, I forgot.
Fucking punishment of the year.
So
No!
we only got
Thank you.
198.
Get that horrible autistic.
Oh!
Hey, man, Brayden, there's a line and you done crossed it.
I
Alright.
have a 98 too.
Cancel.
There were two 98s.
I said horrible.
17
cancel.
That's why it's a
Yeah.
98 times 2.
Oh my gosh. Alright, put your data in.
Oh.
Find your X
don't
bar,
wanna
your
speak that.
S, and your N.
You said artistic?
Oh, that is.
I
I'm
heard
not
all
all
autistic. That's why I said you were ableist.
I was like,
Oh
dang.
my god.
Maybe people
Oh my
should
god.
listen.
Sorry,
Maybe we should learn to speak more clearly.
Never assume.
Is that
Enunciate.
Or don't assume.
Oh my god,
You
he's
should
a Mr. Jones.
clarify.
That's not even assuming if we've heard
Yeah, we
it.
all heard
Everyone
that.
heard it.
I
Right
did
here.
hear.
I feel like I'm being gaslit for real because there's no way.
Sounds like a way
What?
to. Isn't
What
everybody?
about you, Wall?
No, I'm not.
Isn't everybody though? Wow.
My cousin does.
What do
Sorry,
I
just stop
Just
touching
put
me.
temp.
I
Okay.
can't even do this anymore.
It's my head.
You make it whatever you want.
Somewhat.
Is that 97.5 earlier?
Oh, I
So
forgot.
nobody's sick.
Yeah, it says
Yeah.
this.
You have two 97.5?
Oh, good.
These 98s could be
Being
dangerous.
Daniel.
This is why. Because like I said, when you do that, it's really big.
Okay, I'm
Wait.
exactly 98.
I cannot-
So you were slightly over.
There's too many numbers.
But I'm like always cold though. Like,
Because your heat is leaving you.
No, like I never have good
Sounds
food.
familiar.
You're right.
Yeah, like what he said. Like, you know when you know when somebody is sick, you get cold chills, like when you cover up.
Is it? Yes. I heard
Does that mean I'm always sick or like
No,
should I
just-
get
Okay,
like,
since you're a
Some
doctor,
people's
since you're a
body
doctor,
temperature
what does
just
it
runs
mean
hot.
when you're not cold and you're sick, but you're just
Unlike
sick?
Peter.
Just means your
Peter's always
body's
cold
just-
because he's never hot.
Alright,
What?
Some people naturally run out.
So you got all your
of
data in?
temperature than others.
okay. So what is the first thing we need to do? It says, is there convincing statistical evidence that the mean normal body temp is different than the doctor's claim?
We get the mean.
Choose a procedure and everything.
Ah, thank you, yes, well, so, I will say this, let's go ahead and get our mean and our standard deviation and N. Okay, so how are we gonna get all that info? In statistics, stat calculations, good job.
You're welcome.
One variable stats. Hey, how many lists do we have? Just one, right? We only have one set of data. And I'm, no. What?
What lesson was supposed to be?
It's the body temperature one. It's the very next one in the packet, 11.2.
It wasn't right there next to it.
Oh, someone put it in the wrong order. It was not I.
Okay, but
What do you mean?
it says the normal is not.
I see.
I think I'm on the same stuff that Miss Fairview was on this morning.
Okay.
Oh, they said she was geeked this morning.
She was.
Hey,
She was always
geek. She was
Excuse
was
me.
today and
Hey,
yesterday.
have you finished running the
Yes.
stuff?
Yes.
Yeah.
Yeah.
Okay,
Wait,
so
no,
we've
hold
written
on.
down our X bar, our S,
She
and our
was on
N.
that Zaza.
Y'all are going to.
Whoa.
We are going to this thing.
X bar, S, and N at the very top, guys. I thought you were done, Sanaya.
Yeah, I didn't know you were talking about that. I was looking for my paper. At least I was doing something. What about me now?
Oh, gotcha.
Okay.
This is
Si, senor.
just for safety, it's sample mean, not population mean.
Ah, that's a great question. Is it sample mean or population mean?
I missed. Well, no, it's population.
Sample, say it one more time.
I missed, sample standard deviation.
Sample standard deviation or population standard deviation, which one is it?
Sample standard deviation.
Okay, but why should you know we need S and not sigma?
Because you're look at the doctor's claim population wrong.
So what do we not have? We don't have the population.
Yeah, you got 10.
We don't have a population, we have a sample, so SX. Okay, yep. Alright,
Would it be two-tail?
well, we're gonna get there in a second. We haven't chosen our procedure yet. What procedure should we use?
Two sample,
Two
sample.
Wait, I don't know.
One
Is it
sample,
not-
T interval.
One sample, two interval for difference in means.
No.
different.
It's already on.
No, it isn't.
Oh wait, sorry, yeah, I'm stupid.
One sample what?
T interval. I mean T test.
Sorry.
T test.
Oh, we are testing a hypothesis. Be careful. Y'all need to remember, quick hint, I need y'all to look at the original directions. What are two things that tell us this is a test and not an interval?
Alpha statistic.
It gives us an alpha, that's a significance level, that's a test. What else? Say it. Convincing statistical evidence, right? Now we can use an interval for that, but usually both of those things together, usually that alone means hypothesis test. Together they mean a hypothesis test. So one sample T test. Is it for a difference in mean, Serena? What is it for? For a mean. How many means do we have?
One.
There we go. Significance level.
0.05.
Make sure you put that alpha in there. Alpha is 0.05. What's our parameter?
True mean body temperature of all high school students.
Make sure you put the symbol you're using, mu.
Yeah.
The true mean
Of all.
body temperature of what?
All high school students.
It does say of all high school students.
Uh-huh.
Because I guess it could be different if you're old people.
Menopause.
So actually, that is one of the details. Different ages do have different average temperatures. Okay?
Because old people are always cold.
Yeah.
Yeah, 'cause they have less
They're
muscle.
gonna die.
Well, it's also
Blood.
circulation.
Blood flow, yeah. That's a bigger one. Alright, so what's my hypotheses?
No, the true mean is equal to 98.6.
And what's my alternative?
It's not equal, I don't know.
What does it say?
Um,
Say the problem.
Not,
yeah.
just not.
Is
unequal. It's
different than,
Yeah,
so
So it's just not.
not equal to 98.6.
So it's two tails.
So there's gonna be a two-tail test. What's our statistic?
97.72 is not equal to 98.7.
Our statistic?
X bar.
What?
Oh, statistic is X bar equals
Yeah.
97.5.
I thought you were talking about the evidence.
And so what is our evidence?
Yeah, that. What I said.
X bar is
Not equal.
less than,
Not equal to.
But yeah, I mean, it's true, it's not equal to, but it's also just less than.
Okay.
It could be either one. Now, notice that does not, we will have to do a two-tail later, but, check our conditions. What do we gotta check first?
Random. This is not random.
It's assumed.
Yeah.
Pretend like
Let's
it's
assume.
random.
Where at?
Think
That's our
of, the class
says
SRS.
SRS.
So assume the class is, sorry.
Really that funny.
Okay, we got random, what else do we need?
Wait, why do we have adults in the sample? This is-
Yeah,
this is
it's
a-
not-
this is bias.
What?
This
I
is
don't
a
think
bad
it's not high school
idea.
students, y'all are not
I don't think you're a teenager. You're definitely not a teenager.
Y'all are both
There's definitely
Turn
has some
19.
malice in this one.
Wait, no, there's 19 in their birth year, so that means that they're teenagers. Yeah.
What?
Never mind.
Alright, if you wanna take out the 97.3 and the 98, then I will accept that.
I'm
No,
not
I'm
allowed to do
not.
all that. I'm not doing all
Yeah.
that. It's weird.
I know it's
Yeah,
so
I know.
hard. Okay, anyways, we screwed the data, my bad. Okay, so, assuming the class is an SRS, there we go. I was just trying to help us have more data. Whatever.
Oh,
Does anyone actually know why I do want us to have more data? Or did want us to have more?
Because
You really want
small.
us to
the
eliminate?
margin available
Not just that,
makes the thingy narrow, confidence
the-
It's harder for us
Make
to
it
type
more-
in.
For a
The,
better.
the approximate normality thing. I don't know.
Is it for a better
It's
degree?
We have a small
well,
sample.
better degree of freedom.
Yay.
A higher degree of freedom. Like, that actually was one of the reasons why I was trying to get more data, but it's fine. Okay, but assume the class is an SRS, okay, cool. So we got a simple random sample. What's next?
This looks like.
Yeah, it is.
Do I need the 10% condition?
It's not
No,
because
Yes.
well, yeah.
Yeah,
Remember,
because
it's a
this is
random
an
sample.
experiment.
Yeah.
Right, so it's not an experiment, and we are sampling without replacement, so do I need 10%? Yes.
You
Oh.
could have taken that.
So, 10%, is 10 less than 10% of all high school students slash teachers?
Maybe.
Probably, yeah.
I hope so.
I would hope so. Alright, so it's less than 10%, so we satisfied the 10% condition. What else do we still need to check?
Large count.
Yep.
No.
Approximate
Just
normality.
Yes.
So remember, we do need to check approximate normality. What does large counts do? That's for proportions. Don't remember, or don't forget.
Wrong thing.
Yeah.
It's the old thing.
So large counts is the n times p and n times 1 minus p. Wait, can we use the central limit theorem here?
No.
I don't know.
Well, what's the central limit theorem?
Sample
The
size.
sample
over
size
30.
is
Sufficiently large.
sufficiently large.
Like
Oh,
it.
it's not.
Yeah, so definitely, so remember, what's that marker that we usually use for sufficiently large?
30.
30.
Not 30.
So remember, central limit theorem is 30, well, sorry, so the central limit theorem is the sample size is sufficiently large, we usually use 30, okay, for the AP exam. We're nowhere close to that, so what do we need to do?
Make sure it's,
There's no
Assume.
strong
Make sure it's
view
not-
of
Don't you dare
outline.
assume
Menu.
approximately symmetrical.
Dual
So-
pass slide.
Not
Could I create a graph?
Yeah. good graph.
Okay, so I'm gonna go to data and statistics,
This might
Or
be
you could look at
a
the
spreadsheet.
data set.
and temperature.
What's that?
How about that? Does that look like it
Sure.
is heavily skewed or no?
Nah.
Nah. So it is roughly, nope, let me change the plot type. So, Is that roughly symmetric without any outliers?
That was about right.
If I were y'all, I would take a second to not do a t-test, but to make sure you know how to create this graph. You will have to do this on the AP exam if it is ever a t-test.
Help.
Like it makes you,
So, They make you create one, so like,
Velvet pink.
you have to draw it on there, right? So click that, remember,
to make sure.
You real funny looking.
and then I go menu, I would do
You
the
were high
plot
off
type.
sugar,
The
like
plot
white out
type,
scent.
That's how I thought that they would.
I don't even know what to say about it. Like,
Have y'all had
What?
too much sugar?
they said they're high off the
Those
white
two.
outfit.
Alright, that sounds alright, okay.
Sniffing Sharpies.
So remember, on the actual AP exam, you can't just put it on your calculator, you need to what? Okay, so you need to draw it, okay? So, draw graph, but that graph does not show what?
Heavy skews.
No heavy skewness
I don't have no outliers.
or outliers.
One.
So
Approximate.
what can we believe?
Approximately.
Whoa, what is it?
That the sampling
The data.
distribution is
Ah, so reasonable to believe the sampling distribution. You gotta remember that. It's all about a sampling distribution.
Right?
Mr. Kenny, it's approaching the time
Is that
to pass out
maximum?
our BYUs.
It's Hercules.
Yeah.
I gotta finish this first. Okay. So, no heavy skewness.
You also left out.
So it is reasonable to believe the sampling distribution is approximately normal. Calculate, so if conditions are met, which will they be on the AP exam?
Probably. Because they
Yes,
want you to
They
go
should
through
be
it all.
unless, I mean, else you.
I know.
okay.
Okay,
So what's my general formula?
That plus or minus.
Wait, no.
Critical value.
Go back to your.
Critical value
choose.
equals.
No, that's not an interval.
Wait, what's going on?
We're on hypothesis.
I think it's standardized test statistic, right?
Yeah, stat minus parameter over standard.
I thought that was critical value. Oh, no, never mind.
Serena,
I'm
we're not
stupid.
on that anymore.
So here's the thing, the critical value specifically is to get to the confidence level. It's the same symbol, but we call it a standardized test statistic here, divided by standard error, okay? So what's my specific formula?
T star.
X.
No,
What?
it's
X
X
bar
bar.
minus mu.
Actually, she is right that we need to start with T, but again, it's not a critical value, it's not T star, just T. So T equals
X bar minus mu.
X bar minus mu divided by,
S
Wait,
over
what?
N.
No, but no, you haven't assumed population.
huh?
Right, do you have a assumed population? Never mind. Wait, no, I understand it.
We had a null hypothesis, didn't we?
Do you have to assume that the standard deviation?
Remember, we're not, that's why we're using T, we don't have sigma, we use S.
Okay.
Yes.
So,
So, what was our, is 97.72
okay, if you don't have
minus, yeah,
what if you don't have the father dial point? Do they just give you S?
yes, they would have to give you S.
Yeah, because
Okay, hey, 0.31, wasn't it 0.31-ish?
It's point three, yeah, 0.308, so yeah.
308, okay. Divided by the square root of 10. And am I gonna do all that work?
Yeah.
No! Do a hypothesis test. Ms. Kowalski, can you pass these tests out?
Yep.
Y'all, we got calculators, let the calculator do the work, run that hypothesis test. Well, we already have the raw data in the calculator, so what I'm gonna do is I'm gonna go to statistics, stat test, t-test, and I'm gonna do the data. If you don't have the data, you need to do stats, right, but data. And remember, this is the whole reason we've actually done everything up to this point, so we just have to put everything in.
dang, that p-value's tiny.
Isn't it like me?
No, let's be for real here.
So it's not
It's
even.
like Yeah, I know, it's itty bitty.
Hey guys, I want y'all to see something real quick. Hey look, these calculators, if you're in a list and spreadsheets page, you can hit draw and it shades the p-value for you. Look at that. It shaded the little p-value.
Okay.
Oh, it's
Okay. Yeah.
That's quite
Where's thermo at? You can split
Hi,
screen on
Julie.
tablet?
Don't
Oh.
I forgot how to get off this thing.
Wow.
Yeah, I regretted my decision.
I forgot. There's a way to get off the page, but I don't remember this one.
How do I split screen?
I forgot. It's like
It's
control
a
something.
control T, but like it wasn't
Yeah.
working. What did we put this in as? Oh, 98.6.
Wait, hold on.
Alright, so notice our T value. Did everybody else get negative 9 point something
Sure.
with that P value? Okay.
0.0000.
So, I know you gotta go, but I will issue an email for stuff to think about for this weekend and as a reminder. That P value is so low that what are we gonna do?
Reject the
Reject the null. We have convincing evidence for the alternative, right. So make sure you report your T-score, draw out the normal distribution and shade your two tails. and write that p-value and write your conclusion. If you want to ask some questions about your test right now, you can, or email me the questions over the weekend.
I have several questions.
Peter, I want you to shut up.
Let's be for real right now.
Peter, we know how to do it.